Slow me down if you haven't already. Here are our rules for graphing inequalities. So we're going to use an open circle for signs of less than or greater than. See, that's what we mean by an open circle. There's no ink inside of it. We are going to use a closed circle for less than or greater than, less than or equal to, and greater than or equal to. And this is a closed circle. Here's what I want you to see. The more ink you use when you have a closed circle, the more ink you use. That means when you have a closed circle, that number is absolutely a solution. Closed circle means that number is a solution. Open circle means, it's not a solution, it's around that. So here's what this looks like. Let's say I had a number line, and I had x equals 3. If I wanted to graph x equals 3, I would put a dot, closed circle, because that means it's 3. It's 3. And that's it. There's only one dot there, and it's just on 3. X is 3, end of story. Period, end of story. But look here if you have 1. X is less than 3. You have to have an open circle on 3 because that means it's not 3. It's just everything less than 3. So a couple things I want you to see here. In symmetric property, the variable is always on the left-hand side. That's what I've trained you for, right? Variable is always on the left. When you use inequalities, what's so great about it is that when your variable is on your left, this matches the direction of the arrow. So it is a great way to check yourself. This less than means less than. It's going that direction, okay? And it's not 3, it's anything less than 3. All right, so here, x is greater than -1. So is -1 a part of the solution? No, it's not. It's an open circle. It's going to be to the right. And look, this arrow matches the direction of this arrow, okay? Now, number 3, x is greater than or equal to. Is it equal to 7? Absolutely, it's equal to 7. That's why you have that closed circle, and then it's every number that's greater than 7. And my arrow matches this arrow. X is less than or equal to -5. Is -5 a solution? Absolutely. So I shade -5 in, and it's less than, so it's going this way, and this arrow matches this arrow. So that's what it looks like on the number line when you're filling in the number line. Now, if I have to write the inequality given the graph, how do I do that? Well, I know we're dealing with the variable. I'm going to use x as my variable. And my target number here is -2. It's open circle, so it's not equal to, and this arrow matches the direction of this arrow. Okay? Number 6, I'm using the variable x. My target number is 4. Is it equal to? Yes, it is. And it's greater than. So it matches this arrow, and the more ink you have here, the more ink you have here. So x is greater than or equal to 4. Okay, I'm using my variable as x. My target number here is 0. It is equal to, and it's going in less than direction, so less than and equal to. My variable, I'm going to use x. My target number here is -3. It's open circle, so it's not equal to -3, but it is greater than 3. Okay? All right. Let's look at when the rules for solving inequalities. You must flip the inequality symbol when you multiply or divide by a negative number. You must, 100% of the time, flip your sign if you're multiplying or dividing by a negative number. Here's what that looks like. All right, first, here is how we are going to, here's how I want you to solve these. Okay, variable, we already know it's got to be on your left-hand side, symmetric property. I got to get my x by itself, so I'm going to additive inverse, -2. 3x is less than -6. I separate by dividing the 3. and x is less than -2. Not going to spend much time on the solving piece. You should be experts at that. Now, when we graph, and I give you a blank number line, your target number, -2, needs to be in the center of the graph. And then I'm going to fill in integers on the left and integers on the right. So my target number is here, -3, -4, -5, and then I get -1, 0, 1. So it's not equal to, so it's open circle on -2, and it's less than. So inequalities have an infinite number of solutions, so they can go -1 million, and it would be a solution. All right, number 10, additive inverse on -2. X over 6 is greater than -3. Multiplicative inverse, multiply by 6, and I get x is greater than -18. So when we graph, I'm looking for 3 things. I'm looking for the inequality. Actually, I'm just looking for 2 here. I'm looking for the inequality and the number line. Okay, here's my inequality. Target number goes in the middle. 2 integers, or 3 integers in this case, to the left. 3 integers to the right. It's going to be an open circle on 18. And shade to the right. Again, that arrow matches that arrow. Let's do a couple more. Let's see how many more we got. Let's kind of go towards the end. Let's do 17 and 19. We'll do 17 and 19. All right, so here I'm just going to add 2 to both sides. Additive inverse. Divide by 5, separate those terms. X is less than or equal to -1. That's my inequality statement. I'm looking for that. Now I have integers to the left. Ooh, that's a 0. And integers to the right. It's closed circle on -1 because -1 is a solution and anything to the left. Right? Let's do number 19. Here I'm solving for x, so I got to get rid of that 4. Additive inverse is -4, so that cancels out. Be careful, you're bringing down a negative 1/3 x. Now, what do? We are multiplying both sides by a -3. A -3. When you multiply or divide by a negative number, dealing with inequalities, flashlights should go off in your head. Oh, flip your sign, flip your sign. You multiply by negative, switch your sign, I'm left with x, and I get a -21. It is at this point where you switch your sign, because you multiplied both sides by a -3. So my target number, integers to the left, integers to the right, open circle, and shade to the left. Right? That's your refresher on inequalities.